Because welcome once again. So I said yesterday we concluded our discussion on the non-discounted cash flow method, which is otherwise referred to as the traditional method of project evaluation that does not consider time value of money. So the technique under the non-discounted cash flow we talked about include the payback period and the accounting rate of return, which is otherwise known as return on capital employed or return on investment. So yesterday, uh, my explanation on independent and mutually exclusive project was not appropriate, so I decided to give a clear explanation so that when we talk about independent projects, there are projects that can be accepted or rejected without affecting the decision of other projects. Yes, the decision on other projects. For example, I said a company might consider launching a new marketing campaign and investing in a new product line. So these two projects are independent. The decision you make on launching a campaign does not affect the decision on you trying to produce or go into a new product line. So these projects are independent because the decision to pursue one does not affect the decision to pursue the other. So also talking about mutually exclusive projects, there are projects in which they are competing for same resources. So it means your decision on A will make you automatically reject B. So mutually exclusive projects are those projects where accepting one automatically means rejecting all others. That this is a situation where only one project from a set can be chosen. For example, a company might be considering two different sites for a new factory. So when you choose one site, it means the other site is not visible. So it means that in mutually exclusive projects, you have arrays of options. When you go with a particular option, other options have been discarded and you will not have to make your decision about them. So let me come up with this and then we address that. So today we'll be talking about the discounted cash flow, the discounted cash flow method of investment appraisal, the discounted cash flow method of investment appraisal. Now, when we talk about discounted cash flow of investment appraisal, this is a method that takes into consideration the time value of cash flows, or I'll say it takes into consideration the timing of cash flows and the time value of money over the useful life of the project. That is discounted cash flow. Now, it recognizes what 20 naira can buy today. Can 20 naira still buy it tomorrow? So discounted cash flow techniques try to see what will be the present value of a future cash inflow as at today. So, and these will now lead us to looking at two concepts in relation to discounted cash flow method of appraisal, of investment appraisal, as stipulated by the syllabus. So we're going to look at the net present value and the internal rate of return. These are the two, but there are more. We can have issues of modified internal rate of return. We can have issue of discounted payback period. We can have issue of profitability index. We can have issues of adjusted present value, APV. APV is a very important one, even at SFM level, that questions can be tested very well on that. It's an examinable one. But based on the syllabus of FM syllabus, what I've seen, we have to discuss the net present value and the internal rate of return. Yes, and the internal rate of return. So the concept of time value of money, what it denotes that the value of 1 naira of today is worth more than the value of 1 naira tomorrow. So due to price level changes and I would say investors' preference to have cash now rather than keeping it till tomorrow. So these affect time value of money. So the techniques under the discounted cash flow that we'll talk about entails the net present value and the internal rate of return. Based on the slide, I put that discounted cash flow is an investment appraisal technique which takes into account both the timing of cash flow over a project life. There are three important points about the discounted cash flow include that the discounted cash flow looks at cash flow of a project and not accounting profit. Yes, yesterday we tried to differentiate that. We said cash flow is what? Cash flow is what? Accounting profit plus what? Depreciation. So for you to get accounting profit, it is your cash flow minus what? Depreciation. So in a question, they can get it twisted, just as I posted the last question, I think today. Yes, where the question is telling you the net cash flow is this. So you should understand that in terms of accounting rate of return, you use your accounting value. So in that question, you have to determine your depreciation and get your accounting profit. So when you're talking about discounted cash flow, the major point is on cash flow. You can have cash outflow and cash inflow. So the difference between the two, when discounted, will give you your NPV. So discounted cash flow looks at cash flow of a project and not accounting profits. Thus, costs like depreciation are ignored. So the timing of cash flow is taken into account by discounting them. So that is where we'll now come up with our various formulas where in which we use to discount, such as 1 plus r to the power of n to the power of minus n, or 1 over 1 plus r to the power of n, whichever you want to use. So discounted cash flow is concerned with liquidity and not profitability, because cash flow has to do with liquidity. Cash flow has to do with liquidity. So the two techniques to be considered under this method, as I've said earlier, is the net present value and the internal rate of return. So the net present value is defined as increase in shareholders' wealth as a result of undertaking a project. So when we talk about net present value, this represents the difference between the present value of cash inflow and the present value of cash outflow. So in a question, the cost of your investment, what you are paying out to invest, is an outflow. Your expected inflow, cash inflow, is a positive one. So the difference between what you are giving out and what that investment will bring in will give you the difference between the two. When discounted, we give you NPV. We give you NPV. So we give us NPV. So it is one of the discounting cash flow techniques that takes into consideration the time value of money. So the issue of value of money is what you continue to experience as far as you do FM and SFM as time goes on. So it takes into consideration the time value of money. That is, money in the present is worth more than some amount in the future. So NPV is used in capital budgeting to ascertain the financial viability of a project or investment. So a viable project will increase the value of the company, and which will, I would say, invariably maximize the shareholders' wealth. So when we talk about NPV, based on the slide, I said it is the value obtained by discounting all cash flows and inflows. Supposed to make it all cash outflows and inflows. This, Madam Bossade, you want to say something? Your hand is up. All right. So it is the value of discounting all cash outflow and inflows of a capital investment project by choosing target rate of return or cost of capital. These will be given in the question. So NPV method compares the present value of all the cash inflows from an investment with present value of all cash outflows from an investment. So the NPV is calculated as what? Present value of inflows less present value of what? Outflows. So the decision rule for the net present value is to accept a project where the NPV is what? Positive. Where the NPV is positive, or where the NPV is equal to 0. Yes. Or when the NPV is equal to 0. And reject the project when the NPV is negative. So when you are given an NPV question and the result is indicating a positive value, showing a positive NPV, you have to accept. But when you have a negative NPV, you have to reject. You have to reject. So there are various advantages of NPV and disadvantages of NPV, but I will not want to talk about that till when we solve one example. Then we'll now, from what we've done, we'll be able to adjudge if it is simple, if it is complex, and some other advantages that we can come up with in relation to NPV. So to some of us, this topic might not be very new, yes, but it's very important we go over it again. So we have this example. Can somebody read?
I love FM is considering project A with the following cash flow. Year 0, 500,000. Year 1, 300,000. Year 2, 200,000. Year 3, 150,000. Year 4, 30,000. The square value is nil. If the company cost of capital is 15%, we comment whether the project should be accepted or rejected.
All right. Thank you very much. So this is a company, I love FM, which is put forth that everybody in this class should pass FM. So we have to love FM so that at least we'll be among the 4 sets that will record victory. Yes, even as the course is nearly introduced. So looking at this question, that I love FM is considering a project. Please, can you put off your camera? Mr. Timothy. So I love FM is considering a project. It's considering project A with the following cash flows. Now, this cash flow, year 0, the value in brackets, what does this connote? This signifies what?
Cost of the investment.
Investment, yes.
Yes, cost of investment. Now, it shows is an outflow. That is why it is in brackets. Now, in year 1, we have 300,000. Year 2, you have 200,000. Year 3, you have 150,000. And year 4, you have 30,000. That scrap value is nil. That if the company cost of capital is 15%, we should recommend whether the project should be accepted or rejected. But we should recommend. Well, let me show something before we go ahead to solve this. Let me show something. It's something everybody should know. I believe everybody is with his or her book because there is a class exercise you have to solve before we move ahead. So for you to calculate, let's say calculating, let's put it this way, calculating or calculation of discounting factor. How do you do the calculation? I need to show this step. I need to show this before we go ahead to solve anything. It's very important. Yes. So calculation of discounting factor. Calculation of discounting factor. How do you do that? How do you do that? Let me just put and say, let's say discounting factor. Discounting factor is usually multiplied usually multiplied with the cash flows, in order to determine the present value, So I'll now put that it is calculated as follows. I believe some of us should know the formula if you've done PM before. So we can say discounted cash flow will be equal to what? Can be equal to 1 plus R to the power of minus n Now, during the secondary school days, when you step into SS1, they will teach you the law of indices. So anything on this value here that you have, it means if you place 1 as the numerator here, this negative will be removed, isn't it? From the law of indices. So we can say, or this formula can be expressed in another way. If you don't want to use this approach, you can say, or can express it in this way. Let's say, let me use something better. You can express it in this way. We can say 1 divided by what? Divided by open brackets 1, let's say 1 plus R to the power of n. So in this case, there will be no minus. There will be no minus in this at this point here. There will be no minus. So please take note of this. So the point is this. Let's define these variables. The point is this, where, let's say, where R, what is R? You should know that R will be the cost of capital. And N will be what? N will be equal to what? To the useful life. N will be useful life of the project. So when you are given a question and you are given a discount rate, you are given a cost, for you to discount your cash flows, you apply this formula, the discounted cash flow, or the discounted discounting factor. You apply this, where 1 plus R to the power of n. R is what your cost of capital is will be given to you in the question. The N, useful life of the project, will be given to you in the question. So how do you now go about it? Let's now go back to our question. Now, in this question, the cost of capital is what? In this question?
500,000.
The cost of capital?
15%.
15%.
15%. If the company cost of capital is 15%, say 15%. Now, how many years is the project lifespan?
4 years.
4 years. 4 years. So let's now see. Please screenshot this question or write it down immediately in case you don't have it, because I'm leaving this point now. You can screenshot it so that I will not get comments that I should come back to this point. So you can screenshot it in case you don't have it. Yeah. So For us to solve this now, solution, you can have it in this form. Solution. I would just like to present it in a table. Yes, but there are some workings I'll show in the table. There are some workings I will show in the table. Yes, but let me just present using a table.
Mana nke a m ka ha si ga-abata. Mgbe emechie anya ha na-echiji na windo.
Ozugbo, please. Some of these videos I put them on YouTube. Well, that obviously I will not put it on YouTube because I will need to do another one personally and present on YouTube. So maybe by midnight, I can. When you make noise too much. So now we can have it in this way. We can have our table in this form. We can have our year. We can have our cash flow as given to us in the question. We can have our cash flow. We can have our discount factor. At what rate are we discounting? It's given to us at 15%. 15%. Then also, let me just leave this space. We can now have our present value. We can have our present value. And have our present value. Now, in year zero, though some school of thought will tell you don't call it year zero. In that period zero, in the first period, the period of investment, which is term zero, that is a period you are giving out your money as an investment. The cash flow is what? It's 500,000, right?
Yes.
So now, what will be the discount factor at this point?
1.
Okay, why is it 1? Why is it 1? All right, I'll quickly tell you why it is 1. It is 1 because money spent today or money received today is what its full face value. Since you are spending it now, there's no need for you to discount. Yeah, so there's no discount or no discounting is needed. Since there is no time delay, immediately you have the money you are investing. So that period, there will be no need for discounting because the worth of that money is what you are getting at that point in time. So that is why it is 1. That is why it is 1. Yes. So now, at this point, the discount factor is 1. Hope everybody got this information. The discount factor is 1. So what will be your present value? It's 1 multiplied by 500,000. 1 multiplied by 500,000. And when you do that, you have what? 500,000, right?
Yes.
Now, in year 1, your cash flow is what?
300,000.
This is an inflow now. 300,000. So what would be our discount effect? How are you going to discount it? Now, this is it. It will be 1 divided by 1 plus 0.15. R is what? It's
0.15.
Yeah, so 1 plus 0.15 to the power of, in year 1, n will be what? Will be 1.
1 minus
So
1.
No, okay, depend. If you are using this, it will be minus.
I don't know what you're using.
Yes, if you are using this, it will be just be 1 over 1 plus r to the power of n. So whichever, you have same result. So I don't know Can you do that? But I'll just show the process here. Can you do that?
0.8696.
1 divided by 1.15. 0. Point what?
0.8696.
8695.
8696.
Okay, 8696. Let's maintain 4 decimal place. Anyway, so at this point, we have it as 0.8696. So what will be the present value?
260,869.6.
So we have it as 200 and what, please?
60,869.57.
869.510.
57.
Something like this.
0.57. That's what I got.
57. Then the year 2, it will be what?
To be
The inflow 200,000. The discount factor will be what?
0.7561.
Alright, I'm trying to show the workings. So anybody that is wondering what we are doing should see what we are doing. So when you do that, you're going to have what? Please, if your background is noisy, don't worry, don't stop, just follow us. Your background is noisy. Well, once I get noise, I get is a way I get I'm not comfortable sometimes when I hear those noise. So 1 divided by 1.15 to the power of 2, you're going to have what? Your discount factor will be what?
0.7561. 7561. Yes.
So when you multiply, okay, let me just write that here. So what will be your present value?
151,228.73. 228.73.
So at year 3, we have a cash flow of what? So what you do is same thing here. 1.15 to the power of 3. You have it as what?
0.1006.
0.6575.
0.6575.
So 0.65, 0.6575. When you multiply by 150, you have a present value of what?
That's 98,627.43.
All right. So as at the last year, we have it as what? The cash flow is what?
30,000.
30,000. The discount factor will be what?
0.5717. 5718.
718.
Okay. Equal to 0.5718. So when you multiply by 30, you're going to have
17152.60.
60. Mm-hmm. Yes.
17152.60.
0.60. Yes.
17152.60.
0.60.
Why are you having all these points when you have already rounded it up to 0.5718? That means you just times everything with the whole figure you've
Exactly.
gotten.
That's what
That's
they're
why you're getting all these dots 574 and the rest that you're getting. It's not giving you round number. But if you times it with the what as in the original amount given to the 0.5718, we give you the round
Yes,
figure.
you are correct. It's going to give you 17154.
Yes. All this
17154.
is contradicting what we're giving to him.
17154. Yes.
Yes.
You can't write everything now. That's why we are rounding it up. So you now start typing what you have rounded up again to times the number.
What I'm saying in essence that since you have given Mr. Tope that 0.657, when you times it with 150, it won't give you, there is no decimal, it won't give you any decimal at all to give you round figure.
Yes, it's true. The second one is
Okay,
98625.
Is 98,625.
If we are going to go with what we have round up, we are not supposed to get all this decimal. Mr. Tope should decide.
Okay. No, me, I have I just want the class to be participatory. If I want to go by my mistake, that is why I do something.
So the third year will be 98,625. Abi?
Yes, 98,625. Yes, 625. Yes.
So
the first year, the present value for first year is 26880.
Yeah, 26880.
Not 26889.
And the second year is 151,220.
I think I need to go and pick my calculator now.
151,20.
Let me go and pick my calculator, please, so that I'll not be getting all these back and forward concepts. Let me pick my calculator, please.
I just feel using the whole number to multiply the cash flow is more accurate.
Then why round it up again?
Okay, if I understand what the madam is trying to explain, because we've rounded up the discounting factor already. So if we use the old thing we got on the calculator to multiply the cash flow, it's going to, because if someone is reading this, if you're going to multiply this times this, you won't get what we are getting here.
Yes, that's true.
Yes.
Please, what you do for me, when you multiply 300,000 by 0.8696, what do you have? Just give me
have
the back.
26880.
26880.
So 200,000 multiplied by 0.7561 will give you what?
151,220.
151,220. So this.
It is correct like this.
So now the difference between the positive values and the negative value is what?
27879.
Okay, 27.
879.
27879. So now the project is having a positive NPV. So the recommendation will be what? The project should be undertaken because it yields a positive NPV. It yields a positive NPV. Let's write it. So as I'm writing it, this is a question. Can you quickly solve this? That Symbiat intends to invest a project in project A, which requires an investment of 2 million now. 2 million naira now. The project will generate the following cash flows. Year 1, we have 1 million. Year 2, 1.2. Year 3, 400, and year 4, 200,000. So what is the net present value of the project if the discount rate is 8%? So can you solve very fast? Or is there somebody in this class that don't understand what we've done in the example?
So I can't I can't see your screen. I'm just seeing, but let me just, for what you just dictated, year 1 is 1 million, year 2 is
Yes.
1.2, year 3 is
Yes.
400,000, and year 4 is 200, Abi?
Yes.
Okay.
Is there any other person that can see my screen? So make sure you solve. I will just call name at random. You tell me what you've done. Even though I'm not seeing you, I will just call you.
This is what the discounting factor.
Is 8%.
Okay, 8%.
Please go back to the question. Let's see.
Questions, sir.
Is that okay? Please, can someone tell me the cash flows?
Okay, the first year 1 million,
Okay.
second year 1.2, third year
Okay.
400, and the fourth year is 200,000.
Okay.
Thank you. What's the year 0? Sorry. Okay.
2 million.
So who is true now? You know, as you practice, you must be time conscious likewise. You know, sometimes when you're in the hall, you might think you have the whole time to yourself.
I got positive NPV of 419
Yeah.
180.
Your MPV,
490,180.
119, 150. Okay.
180. Positive.
I got 419 180.
Okay.
That's the
180.
NPV.
I also got 419 180.
All right, so that is fine. That is fine. Who is getting something different, please? Who is getting something different? Anybody? Temitope, are you getting same? Mr. Timothy, are you getting same? Or you are still working? Madam Tai, hope you are getting same. You are still working.
Yes, sir, I got the same.
All right. Madam Tolani, are you there?
I'm here, oh, still working.
All right, it's fine. All right. Madam Roots, hope you are fine likewise.
Yes, I was the one that gave answer first.
Okay, fine. Madam Ade, Dayo.
Yes, sir.
All right. Deborah,
I got 419, 180.
all right, fine. So now we can have a situation where the cash flows, where the cash inflows will be same. You have constant cash flows. You have constant cash inflows. And once you see such question, annuity is calling. And what is this annuity? An annuity is simply a series of equal payments or receipts made at regular time intervals for a fixed period of time. So the key feature of it is that equal amount is paid or received depending on the duration. So when you have such scenario, you can use this tabular approach to solve. But there is a more simpler approach where you just use your annuity formula. You use this annuity formula to solve. So this is an annuity formula, which is 1 minus 1 plus I to the power of minus n divided by I. I is the interest rate or cost of capital given to you in the question, while n is the number of years the question wants you to work on. So looking at this question now, Fini is to undertake a project. That project, okay, undertake a project. Okay, finish to undertake a project. I'm writing it 2 times. To undertake a project that require an immediate outlay of 1.5. The project will generate a constant cash flow of 500,000 naira for the next 4 years. The company cost of capital is what? 12%. So for you to solve this, what will you do? You use your annuity formula. You can decide to use your table, fine, but this is a faster approach to doing it. All you need to do is your cost of capital is what? It's 12%, right? It's 12%, which will be what? 1 plus what? 1 plus 0.12 to the power of how many years? To the power of 4 years. To the power of 4 years. And you divide by what? 0.12 again. Divide by 0.12. So we can have it in this form. So this will be 0.12. This will be what? The n is how many years are we looking at? 4 years.
4 years.
This will be 0.12. 0.12. So when you do this, instead of doing the discount factor, why are we doing this? Instead of doing the discount factor for year 1, year 2, year 3, year 4, this is a cumulative. Since they are equal amounts of inflow, so there's no need for us to start solving them year 1, year 2. You can just, but if you wish, you can also do that. You have the same answer. But we're trying to introduce the concept of annuity, that when you have a constant inflow or outflow and you're trying to determine the present value, you can use annuity. So once you get your result here, what do? you multiply by the constant cash flow, which is given as 500,000. So when you simplify this, what will you have? When you simplify this, what will you have? That is 1 minus, open bracket, 1 plus 0.12, close bracket to the power of minus 4, divided by 0.12. You have what?
3.03743.
Okay. So we have it as 3.07, right? 3.037. So now, what will you do? Now, for you to get the net present value, it will be equal to net present value of the project. It will be equal to what? How much are you paying for this project?
500.
No.
1.5.
1.5, sorry.
1.5. 1.5. Now, plus what? Plus your 500,000, which is your constant, multiply by that result, 3.037. You're going to have what?
151,500.
So we're going to have it in this form. You know, this 1.5 is minus, let me remove it from bracket. It's the same thing as minus 1.5 because it's an outflow. Plus, so once you multiply 500 by 3.03, you said it's what?
151,500.
151,8650. What did you like? Okay, you approximate it to 7. Sorry, I used more than, I used 0.3.0073.
151,500.
158,500. So we have it in this form. So the difference will now be what?
18,500.
18,500. So your NPV is now what? NPV is equal to what? 18,500. So at your leisure time, you can use the tabular approach. You can use this the tabular approach and do it year by year. But you know, when you're using the tabular approach, you use this approach 1 all over 1.12. You understand? Yes, for year 1. For year 2, it will be 1 all over 1.12 to the power of 2. You do it in that way. You write your various cash flows, 500,000, 500,000 continuously. But instead of doing that, we are now bringing this concept of annuity. Why? Because they are constant cash inflow. Constant cash inflow. So that is why we are using that. Madam Chikodili.
Yes, sir. Maybe it's me that don't know how to press calculator. I've been trying to get 3.037.
To press your calculator needs special class likewise. Yes, it's because sometimes you can spend 30 minutes in trying to get a figure because we don't. So how are you pressing it?
1 minus bracket 1.
No, this is what you do first. Do the bracket first. Do 1 plus 0. Just 1.12 to the power of minus 4. That is what you do first. And once you get the result, you now say 1 minus that result. Then you'll be fine.
Okay.
You get you do it the bracket first. Don't combine everything. Your calculator does not have that brain.
Now, wow.
So let's move forward.
Okay, sir.
But please try and get it, please. So we'll now move to these aspects, the internal rate of return. The internal rate of return. I was trying to to write my notes, but I was not able to conclude it before the class. So when we talk about the internal rate of return, there are different names to it. So in the exams, they might not use internal rate of return. In the exam, they might not use internal rate of return. But the examiner wants you to solve a question using internal rate of return. So this internal rate of return is also known as marginal efficiency of capital. It can also be referred to as cut-off rate. It can be referred to as hurdle rate. It can be referred to as break-even cost of capital. Break-even cost of capital. So the internal rate of return, when we talk about this internal rate of return, we're just trying to look at, it is the rate of return, or is the discount rate that makes the net present value of the project to be equal to 0. The discount rate that makes NPV to be 0 or minus anything 0 below, minus, because when you solve some questions, you might not get 0 perfectly, but you can get minus 0 points. It shows that you can use that discount rate for your tax. So the internal rate of return is a discount rate that makes the net present value of a project to be equal to 0. So when we talk about internal rate of return, the internal rate of return can also be interpreted to mean the maximum rate of return that a company is expected to earn on an investment. So it is the rate of return where present value of inflow, listen now, where present value of inflows equals outflow. That's why we're talking about break even as one of the instead of them telling you compute internal rate of return, they can tell you calculate the break even cost of capital. I've seen a question like that. So what they want you to do is for you to use to compute internal rate of return. As a matter of fact, if you go to performance management, I think that was a question we solved during the revision class last diet that involved this. They didn't use internal rate of return. They use break-even cost of capital. Yes, to tell you that if you don't know the different names of internal rate of return, you will say these people have come again. They want to kill somebody. So the internal rate of return will be calculated using what we call the interpolation method. Interpolation method. Yes, that is internal rate of return. Interpolation method. Don't mind the grammar. Interpolation is not any big thing. It's what you will solve, and it's what you know and you can know in case you don't know it before now. It's not any big thing. So you use interpolation method to determine that. So I will show the steps involved to solve the internal rate of return. I will show the steps involved. I was not able to write down all I need to write. So before it's time for the class, so let me just say step 1. Step 1. What do you need to do? What do you need to do when you're asked to compute internal rate of return? What do you need to do? Step 1. Let's see what we need to do. Now, I'll say calculate the net present value. Calculate the net present value. The net present value using a trial and error approach. using a trial and error approach. It means you have two rates of two MPVs. One will be positive, one will be all right. You have two MPVs. One will be positive, one will be negative. So I said calculate the net present value using a trial and error approach. Yes. Let's say by selecting an arbitrary. Yes, I will say arbitrary. You just think of one rate, or you can use the rate given to you in the question. If a rate is giving you a positive net present value, it means the next rate you have to use should be more higher so that you can have a negative net present value. So we'll show the formula, we'll show the interpolation approach and everything. So very quickly, calculate the net present value using a trial and error approach by selecting arbitrary cost of capital. Arbitrary cost of capital, which may gives positive or negative NPV. So as a rough guide, let me just put this as a rough guide, but it might not be necessary. As a rough guide, in case you are very fast and you not get confused, as a rough guide, let's just show it. As a rough guide, let me say you may first compute the accounting rate of return, and then use, I'm just putting this, it's not necessary please, and then use, in case you think you can, and then use 2/3 or 3/4 of the accounting rate of return as your discount rates. So the major thing is calculate the net present value using a trial and error approach by selecting an arbitrary cost of capital, which may give positive or negative NPV, which may give negative or positive NPV. So the step 2 is this. Step 2, we can say if NPV computed, let's say in A is positive, use a second rate. That means if you use 15% and your NPV is positive, what will you do next? Use a second rate, because you need to get 2 NPV. One will be positive, one will be negative. Use a second rate that is what? That is higher. That is higher than the first rate. Please get this statement so that when we solve, you don't start thinking. The point is, in exam, if you use 14 and I use 15, somebody use 17, everybody will pass once you are following the steps, because you definitely get same results. Yes. So because when we start solving, somebody will now ask me that how will you know the rate to use, the rates not to use? The step is, once you use, let's say 5% and you are getting positive NPV, I can increase it to 12%. Once I increase my rate to 12%, I will definitely get a negative NPV. So somebody else who is also a student writing same exam can use something else. So don't think you must use same rates. Yes, that's why it is called trial and error approach. So the fact that we're writing same exam does not mean your rate must be same with my own. Just follow the steps and you get your answer. So that is it. That is it. So use a second rate that is higher than the first and the first rate so that you can, that is, let's say, to give negative, so that you get negative NPV. So let's now put it in another way. Let's say if the NPV computed, in A is negative, I'm putting it in another form, use a second rate. Use a second rate that is what? That is lower. That is lower than the first rate. Please take note of this small grammar. So to give positive NPV, to give positive NPV. So if the NPV computed in A is negative, once you use, let's say, 10%, you are getting negative. For you to get positive, you can reduce it to 5%. Why are we doing that? You need 2 NPV for your interpolation. You need 2 NPV for your interpolation. And one of the NPV must be what? Positive. The other will be negative. So step 3, what should we do? In step 3 now, let's see. Step 3. What should we do in step 3? In step 3, let's say use the 2 NPV. Use the 2 NPV values generated. Use the 2 NPV values generated to determine the internal rate of return. The internal rate of return. And which formula are you going to apply? And let's say, and the formula to apply, let me say, is this. Formula to apply is this. I think I have a formula somewhere. And then if I can locate it now. So let's come up with another one. Let's come up with our own now. Let's write one out. Internal rate of return will be equal to A. I'll define everything. There are different formula. If I go to I have some other slide that I use for my SFM class. There is a way I put the definition of the formula, but for this class, let me put it this way. We can have A plus, let's say A plus. I'll define what A is. Yes, I will tell you what A is. Let's have it this way. A plus, let's say A plus, let's say NPV of A. Let me make this lowercase. NPV of A. Take note, when you go to some other book, as I'm saying, they can put it in another form, but it's same application, please. Divide by NPV of A again. NPV of A again. And make it this way. NPV of A. Sorry, let me just undo. NPV of A minus MPV of B, all this you multiply by what? B minus A, B minus A, B minus A. I think you should be able to understand this in this form. B minus A. Let me make it subscript. B minus A. So now, what is A? The question is, what is A? You must know the definition. A is what? The lowest discount rate. Lowest discount rate. You use to get your MPV. And B is what? B is what? Highest. Highest discount rate. Highest discount rates. And MPV A is what? Is equal to what? That is the MPV that gives positive MPV using the lowest rates. Using the lowest rates. And MPV B will be what? Will be equal to MPV that gives the negative MPV using the highest rates. Using the highest rates. So this is how it works. So in a normal situation, MPVA will be positive, while MPVB will be negative. Since MPV will be negative, you will be subtracting negative. You know, this MPVB will be negative, right? You know, it will now be minus, isn't it?
Yes.
Minus. This MPVB will be negative. So it will now be minus times minus. So what will now happen? It will change to positive. To change to positive at that point in time. To change to positive at that point in time. So let's see. Yes.
So this your formula, I believe that there's no equals to after plus A plus.
No equal to. Let me delete it. I just there's no equal to. Let me see. Okay, fine. Yes. So you have it this way. Let me see. I have an example now. Let's see if we can get an example to solve in relation to this. Because I'm just trying to all right, let's take this example. Let's see. Let's take this example to illustrate some internal rate of return. Let's see example. Let's see. Example. Let's see. Now. Let's see Debbie Limited. Debbie Limited is considering a project B Limited is considering a project with the following estimated say future cash flows. Estimated future cash flows. Estimated future cash flows. So we can have it this way. Let's present this and say this way. So we can have year, we can have cash flow. Then let's say 0.0, it is 150 at 1, you can say it is 60,000. 60,000 at year 2, you can say it is what 75,000 at year 3. You can say it is what 50,000, and at year 4, you can say it is 25,000. 5,000. The question would be, let me put it, the question would be that okay, let's say the company's costs of capital. Unit cost of capital is 10%. It's 10%. So also, the point is required. What is the internal rate of return of the project? And advise if the project should be undertaken. Advise if the project should be undertaken. Advise if the project should be undertaken. Now, there is something I didn't mention in internal rate of return, the decision rule. Decision rule is to accept a project if the internal rate of return is greater than or equal to the company's cost of capital. Please put that down, though I will still add that to my notes. I was not able to formulate the notes before, but let's note that for you to accept for independent projects, you accept if the internal rate of return is greater than or equal to the company's cost of capital. And for mutually exclusive projects, the decision rule is that accept any project with higher internal rate of return, provided that it is greater than the company's cost of capital. So that would be the decision rule. Now, in this question, the company's cost of capital is what? It's 10%. 10%. So anything you are doing.
Sir.
I'm with you, sir.
Sir, can you recap that statement, sir? So I can get it.
That's the decision rule. We need a sort of a recap, sir.
decision rule. Accept, accept. If internal rate of return is greater than or equal to the company's costs of capital. This is the rule. So whatever you are computing, for you to accept a project, the internal rate of return you compute should be greater than the cost of capital given to you in the question. That is the decision rule, either for independence or for mutually exclusive projects. So what you computed should be greater than what is given in the question. So now, looking at this question that we've put forth, take notes. You can use any rates. If you use the first rate and you are getting a negative, maybe a higher rate and you're getting a negative, what will you do?
Lower. Use lower one.
You use a lower one. So for the purpose of this class, I will use my own. When you after the class, you can go and use your own rates. Anything you discover, you still get. If you follow the principle, you get a rate that once you use that rate, you have an NPV that will be 0. So first, I want to assume 15%. I want to assume. Let's assume.
But the question is 10%.
That is the company's cost of capital.
Okay.
If you want, you can still use 10%. Then you look for another one. If it's giving you yes, but I don't want to use that 10% so that somebody in the exam will not think it's compulsory you use 10%. You can use any rate. You understand? Yes. The point is use one that will give you positive, use another that will give you what? Negative. The point is any rates you adopt, once the IRR is greater than the value given in the question, 10%, it shows you have to accept. The cost of capital given is 10%. So anything we are doing, we should be able to arrive at anything higher than 10%. If it is not higher than 10%, it means we are going to reject the project. Yes. So let's assume 15%. After the class, you can go and assume anything. Yes, so that you test your understanding. So we want to assume 15%. I want to assume 15%. So let's say we have it in this form. Assume 15%. So for the years now, what do we have? For the years, we can have years, and we can have what? We can have the cash flows. We can have the cash flows, and we can have the discount factor. I'm saying I'm using 15%, and our present value will be what? So for the year 0, we have year 1, we have year 2, we have year 3, and also we have year 4. We have here 4. I believe everybody have a question. This is it. This is the question. Debit limited. So now, in year 1, the cash flow is what? There's initial outlay. Initial investment is what? Is 150. It's 150. So at this point, the discount factor will be what? 1. The present value would be what? 150.
150.
So at year 1 now, the inflow is what? Cash inflow, 60,000, right?
It's 60.
So the discount factor at this point will be what? We are using
0.8696.
0.86.
8696.
8696, something like this.
Yes.
Then when you multiply by 60,000, you have what?
52,197. Well, 176. 52,176.
176. So at year 2, the cash flow is what? 75.
75,000.
Now the discount factor will be what?
52,70, approximately 708. 56,708.
Can you check that again?
It's 56.
No, it will be 0.7561.
0.7561.
75,000. Okay, sorry, I've done it. 0.75. I've done it. I've done it on my paper, Sandra.
So the result here will be what?
76,701. 71. I mean 70.
707.5.
Can I get a precise answer? When you multiply 75,000 by 0.5,
Approximately.
5607, approximately 8.
8.
56,708.
then for the third year is what? 50,000.
50,000.
The discount factor will be what?
0.6575.
0.65.
75.
75. Then when you multiply, you have what?
32,875.
32,875. The fourth year, we have what? 25,000.
95,000.
Then the discount factor will be what?
0.5718.
0.5718.
18.
When you multiply, you have what?
14,295.
14,295. So the difference between the positive values here and the negative will give you what? Are we having positive or negative?
6,054. Positive.
MPV is positive. 6 what?
6054.
2054. So this is 15% is giving us a positive value. I will want to
Yes.
increase it. I will increase it to 18%. Let's see if it will give us a negative value. So let's assume 18% now. Assume 18%. Assume 18%. So we now have it as what? 18%. Delete all this. So the discount factor here at year 1 will be what?
0.8475.
475.
So when you multiply, you have what? 60,000 multiplied by 0.875.
That's 5850.
At this point, the discount factor will be what? Is 1 all over 1.18 to the power of 2.
0.7182.
0.71. Can you confirm that again?
0.7182.
Somebody else should confirm.
Someone should confirm.
Somebody else should confirm.
0.7182. 0.7182.
82. So when you multiply, you have what?
Ah.
3865.
Blessing, máa pè ẹ́ padà, mo wà ní class, máa pè ẹ́ padà.
53. 53.
53,864.
Now, for this, it will be what? Hope every other person, hope you are following.
It's 53,865.
53,865. So for this, we have it as what? Discount factor at 18% for the third year.
0.6086.
0.86. When you multiply, you have what?
30, 430.
Okay. 30, 430.
430.
Right. So for the fourth year, you're going to have what?
0.5158.
5158. When you multiply, you have what?
12,895.
12,895.
895. So what will be the difference now? When you add 5850 plus 53,865, 30,430, 12,895 minus 150. Are you getting positive or negative?
Negative.
Negative
1960. 1960. Negative 1960.
So with this now, we can now apply this to compute our internal rate of return. We can now compute our internal rate of return. So let's copy this. Let's copy this now. Let's copy this formula. So we have it. Calculating internal rate of return. So now, I believe you have the definition of each of these formulas. Now, internal rate of return. A is what? A is what?
Lower
It's 10%.
Lower discount rate. Lower discount rate. The lower discount rate we use here is what?
It's 10.
15%.
15%.
Okay.
15%.
Plus what?
Ah.
The MPV is what?
MPV.
MPV of A.
6054.
6054. See it here. This one that way here, 6054. So when you have this now, this will also be what?
054.
054.
And it was 1960.
So,
One nine
you know,
six.
this is a negative one, right?
Okay, yes, that's true.
So we now have it. What was the result here?
1960.
Minus
1960.
60.
Minus. Okay, it's in bracket.
So B is what?
It's 18.
18%.
18%.
Yes, discount rate.
10%, right?
Yes.
So when you bring this down, internal rate of return is equal to 15%. When you simplify this, 6054 minus 1960, it will be what?
80, 14, 8014.
Yes.
You know, this one is having minus. So minus times minus, it will change to plus. You get that?
Yes.
Yes.
Plus. So when you add
points. Okay.
8014.
The denominator will be 8014.
014. 60.
So we now have it as what? 15% plus what? When you simplify, you have what? 60.
6054 divided by 8014.
8014. Multiply by what?
Multiply by 3%.
3%. So when you divide this value, 6054, what will you have?
To give you
0.7555.
You have what?
0.7554.
554. Multiply by 3%.
Times 0.02266.
Okay, let me just show it gradually, because so we now have it as 15%
Plus
what?
0.0226 or 2267. I don't know how we
Convert it to percentage.
Okay. Times 100. That's 2.26% or 2.3%.
0.3%. So your IRR will be what here?
That will be plus 15. That's 17.2.
17.2.
So you can just say 17%.
17.3.
So you can just say approximately your internal rate of return approximately is, let's just say 17%.
Okay.
17%. So comparing this value here with what you have in the question of 10%, should you accept or reject?
Accept.
Accept. You accept. But let me now, you know what you do for me? See this 17%. This 17%.
Yes, sir.
Go and use it. You will use it at this point. You place it here. Do you understand? So you should have an NPV of 0.
Oh.
Do you get that?
Okay, sir.
Yes.
I didn't get
so
it. The network was bad. I couldn't hear what you were saying.
So this 17%, you know, is our internal rate of return.
Yes.
So this is where the question wants you to stop.
Okay.
But as a proof,
Yes,
that at this point, at 17%, your cash inflow and outflow will be 0. So go and use this 17% as a discount factor. Do you understand? As a
Okay.
discount factor here. Use 17% as discount factor. Do you understand?
Okay,
Then
sir.
by the time you solve, you should have MPV of 0, or you should have minus, yes. So in that order. So that is a proof. For knowledge purpose, that is why I'm saying this. Because
Okay.
if you go to your books, they will just stop at this point. But what is the meaning of this? The meaning of this is that at this point, you will experience break even. Your cash flow, cash outflow, and cash inflow will be equal. That is the interpretation of this. So as a proof, you go and use this as your discount factor. You understand?
Okay, yes, sir.
To have a good knowledge of why this is like that. So that you not just see figure. I know how to compute IRR, but what is the meaning? Do you understand?
Okay,
So
sir.
let me just give a statement. The project, let's say the project internal rate of return of 17% is higher than the company's costs of capital. It's higher than the company cost of capital.
Okay.
Cost of 10%. Let's say hence the project is financially viable. To be and should be undertaken. So this is internal rate of return. This is internal rate of return. So I can see some hands up.